Hello everybody, welcome to BlueMarbleScience. Gas pressure without a container, round 2. Or, how to step on one of these. Apparently a lot of the Oakleyites aren't too happy with Gladys and myself. They now seem to believe that an open top pipe constitutes a container, but you know there's a problem with that. It's not what Nathan and his team were saying until they saw the original video. So Gladys, are you ready? Hey Dr. Bob, hold my beer. Let's light this dumpster fire and have some fun. Well, let's start with this comment from the Sleeping Warrior. BlueMarbleScience, you lying sack of shit. Our words are you cannot have gas pressure without a container. We do not say it is sealed or open. It doesn't matter if it's open or not. What matters is that it's contained. We cite literally the definitions of gas pressure. You are dishonest and wrong. Like every baller, I love how you are moving the globe posts, and even when you do, it changes nothing. You are lying, wrong, and incapable of tying your own shoelaces. My goodness, I seem to have annoyed the little fellow. Well, I'll tell you what, let's see who's moving these globe posts, shall we? But before we do that, let me remind you of one thing, Anthony. An open-ended piece of pipe is a gas container in the same sense that this is a gas container. I've got a great idea. Let's ask the quantum eraser. Hey, QE, is a gas container sealed or open?
But if the container is not sealed, the gas will escape. But if the container is not sealed, the gas will escape. But if the container is not sealed, the gas will escape. So, number one, where's the container? And it better be a sealed container. And it better be a sealed container. And it better be a sealed container surrounding the Earth, because the gas is going to escape. This is simple.
Now, back to your comment, Anthony. That was pretty clear, I think. QE defined a container as a sealed pressure vessel. QE's exact words were, and it better be a sealed container surrounding the Earth because the gas is going to escape. Open pipes aren't sealed containers, Anthony. And you, my friend, are a sheethead. There. That looks pretty good. So, I'll tell you what, let's let Betty have a crack at this, shall we?
Well, but with this kinetic energy, with these particles shooting up, I mean, why would they lose their kinetic energy? Also because of the temperature, of course. But I mean, we have these Newton laws, right? Where something in motion will stay in motion until it's being deflected.
Oh, no.
Yeah, they bring that up also, right?
Newton laws for gas?
But then that would help, I think, that you have these walls of the container, so these particles will press on the walls. So you have to have an upper wall, basically, a ceiling somehow.
Yes, exactly.
Yeah. If you can follow me.
Yes, yeah. That makes perfect sense.
And then, of course, there is the man himself.
You can do. I just wanted to slip in that one debating point, which is when they get to that stage that Betty's got to, I ask exactly that. What's it pressing on at the top? Because at some point there's gas pressure. It doesn't matter how gradiated you make it.
And then there's this demonstration. By the way, pay careful attention to the way Quantum Eraser refers to the SF6 gas cylinder as a container. but he calls the open tray a fish tank. Now, which one would you say is more similar to an open-ended piece of pipe?
So, the sulfur hexafluoride trick. So let's go back here, and I won't play it, so we won't get any copyright strikes. So you see back here, this is the sulfur hexafluoride, right? They bring in the sulfur hexafluoride, and they're going to put the sulfur hexafluoride in this empty, looks like a fish tank. It's got a cardboard cover over it, right? But my question is, why did they bring the sulfur hexafluoride gas into the classroom with the container? I mean, that's our argument, right? Roger. So this is a container. Why didn't they bring it in like a milk crate? So you're just supporting our argument here. Let's take a look at this. So they're going to fill this tank up, right? They got their little hose there. He's turning the valve. He's opening the valve of the container, right? So let's see where he goes here. He's putting it in. Let's see if we get a good look at that cylinder in back. I'm going to have to take a good look at that. Should be coming up here any second. Oh, so the lid. Why does he have a lid? Why is there a lid on this? Right? Let's take a look at that. Oh, there you go. Maybe here in a couple seconds. There we go. There we go. A little bit more. He's not going to give it all to me, is he? Okay, see the cylinder right here? Why do you need that cylinder? I mean, this is our argument that you have to have gas to have gas pressure. You need a container. Well, they're satisfying this rule for us right now. There's a container. So let's continue. So let's see what they're going to do. They're going to take the top off, right? There's a good picture of the valve stem and the container, right? And now we get our aluminum foil boat, right? This is really amazing. I love this magic trick. So he's going to put the aluminum foil boat down, and oh, it floats. It's magic. What else are they going to do? Notice how fast, after he took the container lid off, right, that they put the magic aluminum boat in there. It was real quick, right? They put that in there real quick. Keep that in mind. So there they go with their boat, and they start pouring stuff in. Wow, that's really magic. Love it. I'll bet you the kids loved it. Okay. So, my questions. What's in the gas tank? Again, what's in the gas tank just behind the fish tank? Number 2, why is there a lid over the fish tank when the sulfur hexafluoride gas is added to the fish tank? Number 3, and this is a sidebar, is sulfur hexafluoride gas a man-made gas, or is it a natural gas? That is, if man wasn't or didn't exist, would sulfur hexafluoride exist? If so, is it available for scientific inquiry? But that's not the real game here. See, I've been waiting. This is the question. This is what I want them to do. We would like to see the same demonstration 3 hours after sulfur hexafluoride gas is added to the fish tank. That's what we need to see. I want the gas added. You can have your little cardboard lid over it, no problem. I put the sulfur hexafluoride in, leave for 3 hours, and come back. We want to see that. And then put your little friggin' aluminum foil boat in there, and let's see what happens. And define a false equivalence fallacy from the Black Lagoon. Okay, let me stop right here just for a little bit. Any comments on this?
Feel free, whoever wants to go first.
No, I think it's really good explained here that the gas, it is still a gas. It will dissipate, I think. And although it might be a heavy gas, it will still leave the tank eventually, even with a cardboard lid on top of it.
Right. It'll increase its entropy, right?
Yeah.
And fill the available space or the given volume. Exactly.
Yeah, the other thing you highlighted was that it's not natural gas, and obviously it's got a very high density, hence it's sitting in the tank after being pumped in from the pressurized canister that was used to wheel it into the classroom rather than an open top wheelbarrow. Nevertheless, you're still going to have the same effects of entropy. So yeah, it's a man-made gas, but it's a demonstration that's probably very short-lived. Well, certainly short-lived because of the law of entropy. we know precisely what will happen to that gas, considering that there's no bonds, there's no barrier, there's nothing stopping it from, over time, suffering the effects of entropy and dissipating into the rest of the room, which is precisely what would happen in about 3 hours, probably less, probably an hour, it would do the same thing. I'd be surprised if in half an hour they could still stick the aluminium boat in, actually, John, if having thought about it a little bit. I think half an hour would be enough for it to just not have the same effect, and you stick it in it would just go straight to the bottom.
Oh, yeah, it's not going to be there even with 30 minutes.
But yeah, I think 3 hours is enough to, it's not an intolerable amount of time to ask. But yeah, I would want to see that demonstration too. Let's see that the effects of entropy don't suffer. It doesn't suffer the effects of entropy.
Well, talk about moving the goalposts. You guys presuppose the non-existence of gravity, and that comes with a lengthy list of logical fallacies, beginning with the mother of all arguments from ignorance. Gravity has been proven. You guys cannot disprove it. You need to walk away from that one, ladies and gentlemen. You're just making yourself look more and more foolish. In your amateur vernacular, you clearly equate a pressure vessel with the word container, but now you want to redefine it. You argue that an open pipe, by your new definition, is now a container, even though you repeatedly stated the requirement for a sealed system that universally applies to a gas, and even discussed at length how gases behave differently than liquids. That's in the original Ballbusters video, and I'm not going to repeat or replay that here. Go there and look for it if you want to look it up. Finally, you made the unequivocal claim that gas in an open system, regardless of its density, would dissipate into the atmosphere due to the law of entropy. And you would be correct if it were not for gravity. But you even gave us a time period of 3 hours beyond which you guaranteed a heavier gas would have dissipated into the room. You just got through saying it. I can't believe you guys walked into this one. Let's watch the very back end section of my video. Well, it's been well over 3 hours now. Our gas pressure is still sitting here quite happily. You'll notice a slight variation from time to time. The wind is blowing a bit, but it's exactly where we left it. Did you guys think I arbitrarily selected 3 hours? Did it not occur to you that maybe I put that bear trap in there just to see what you were going to do? 3 hours is what you wanted to see. Let's listen to your words again.
I'd be surprised if in half an hour they could still stick the aluminium boat in, actually, John, if having thought about it a little bit. I think half an hour would be enough for it to just not have the same effect, and you stick it in it would just go straight to the bottom.
Oh, yeah, it's not going to be there even with 30 minutes.
But yeah, I think 3 hours is enough to, it's not an intolerable amount of time to ask. But yeah, I would want to see that demonstration too. Let's see that the effects of entropy don't suffer. It doesn't suffer the effects of entropy.
The pressure remained constant actually for closer to 4 hours, and it would have done that for 4 days if I had wanted to leave it out there that long. But it only did that because of gravity. If gravity didn't exist, what you would have seen is an actual violation of the second law of thermodynamics, and we all know that's impossible. Now, there's an easier way to show atmospheric pressure, and it's called a Torricelli vacuum. A guy named Torricelli made the very first mercury barometer in about 1650, and it measures directly the air pressure of our atmosphere. Here's a video. Take a look at that, and then we'll talk some more.
We're going to make a barometer. And what I have here is a glass tube that's about 800 millimeters long. And I've filled it with mercury almost to the top. And I'm going to finish filling it so that I get filled all the way to the very top. And then I'm going to put my finger over the end, and I'm going to invert it into the mercury. I'm going to set it here and use our clamp to hold it. Now, what's keeping this mercury column so high? It's that atmospheric pressure pushing down on the mercury, pushing this up. And let's see how tall our column is. 744 millimeters. It doesn't matter what size the diameter of our tube is, as long as it's relatively small. You can see this one's really small. I have another one that's almost twice the diameter of this one. But you can see that the level is the same in both tubes.
You may want to pause the video and go wash this stuff off your face before we finish up here. Well, the lady in the previous video is from the University of North Carolina School of Science and Mathematics. And I am perfectly willing to do that same experiment, but somebody's going to pay for it, not me. Mercury is fairly expensive, and it may cost even more to dispose of it than it does to purchase it. So anybody wanting to ante up, I'll be more than happy to duplicate what she did. I'll even put it in a vacuum chamber and show you that column of mercury all draining down into that little vial. It'll work. And I want to say something else too. That this video that I was responding to goes much farther than just talking about pressure. They also talk about the pressure gradient at the back end of it, and it is unbelievable. You should look up Ballbusters 5 video and watch it, or look at my video on that same topic. Basically, what they end up doing is blaming pressure gradient on the carbon cycle, the nitrogen cycle, and the water cycle. In other words, their explanation for pressure gradient boils down to petunias, fertilizer, and rain showers. Okay, we've done this before, but let's do it one more time. Are you guys ready for the truth? Gas pressure easily exists without a container. It produces a pressure gradient that is exactly what we see in the atmosphere. The pressure gradient and pressure are produced by gravity. You can complain about this all you want to, but gravity doesn't require your permission. You can't disprove it. You'll never disprove it because it's real. And empty space is not only possible, it is completely undeniable. So, you say we can't have gas pressure without a container? I gotta say, bull. Hey, thanks for watching. Don't forget to hit the like and subscribe. And Gladys, we're out of here.